Hello everyone, welcome to Code with Me YouTube channel. Today we will be discussing about another problem of our data structure and algorithm course of basic mathematics. So before I proceed, I would request everyone to please subscribe, like and share. So, so our today's problem statement is we have to check whether a number is prime or not. Okay, so the user will give us a number and we have to check whether it is a prime number or not. So here I will show you two implementations. One is the naive implementation and second one is the efficient implementation. Okay, so let's begin. So first of all we will take accept number from the user. Now I will create one function bool check prime and pass the number that is given by our user. Now first of all I will write the logic, then I will explain you. So let me first explain you this function which I have created, that is check prime. So what it is doing, that we know that first of all what is a prime number? A prime number is a number that is divisible by 1 and the number itself. So here we are not taking consideration of 1. So 1 is not taken into consideration. If 1 comes, it is neither prime nor composite number. So we will return here false. If n equal to 1, we will return false. Now we are starting a loop from 2, because 1 we have already considered. Now we are starting from a loop from 2 to less than the number. Then we are checking if, suppose if I have taken the number 3. Okay, is 3 equal to 1? So it will return no, false. So it will not go into this condition, so it will go into this condition. This is considered as an else condition. So it will go into this condition and it will start loop from I equal to 2. 2 is less than 3, yes. So it will check 3 modulus 2 is equal to 0, no. So next I will get incremented by 1, so it will become 3, I equal to 3. 3 less than 3, no. So it will come out of this loop and will return true, means yes, 3 is a prime number. Okay, and in the main function we have specify that if check prime, if it means that the check prime function, if it will return, this will either return as true or will return as false. So if this check prime function is equal to true, then it means that yes, it is a prime number, else it will return. If else it is false, then it will go into this else condition and says that no, it is not a prime number. So this is one approach how to check for the prime number. So let us check whether it is giving us the right output or not. So let's compile and run it. Suppose if I have given the number 8. So is 8 a prime number? No, because 8 is divisible by 2, 4 and 8 itself. It is not divisible by. So it should give us not a prime number. So let's see. We'll press enter. So yes, it is giving us not a prime number. Now let us take a prime number as our user input. So let's take 11, because 11 is a number that is divisible by 1 and the number itself. So 11, so it will enter yes, it is a prime number. So we say that yes, our implementation is correct. So this is one approach. So another efficient approach is, first I will implement, then I will explain. So check prime efficient and n. Okay, so if n equal to 1, return false, else for int I equal to Here we will also specify some extra conditions. If n equal to 2 or n equal to 3, because 2 and 3 are prime numbers, so we will specify that yes, it is prime number and we will return true. If n modulus I, if n modulus 2, if it is equal to 0, or n modulus 3, if it is equal to 0, we will return false, because if a number is divisible by 2 or a number is divisible by 3, so it means that it is not a prime number, because 3, if it is 3, then it is prime number, but if it is 6 or 9, so it is not a prime number. So we have specified in this condition. And now we will check for other numbers, that is 2 multiples of 2 and multiples of 3 we have covered in this statement, because if there is a multiple of 2 and which we are checking that if it is 2, then it is prime number. If it is 4, 6, 8, so it will return as false. If it is multiple of 3, then it will also return as false. So next we have to specify for int I equal to 5, I less than I into I less than I into I less than equal to n, I plus equal to 6. Why incremented by 6? Because we have specified I equal to 5. So for 5, if I increment by 6, so it will, if I increment by 1, it will give us 6, but 6 is already covered in this statement, because 3, because it is 6 is a multiple of 3, so 6 modulus 3 is equal to, so it will automatically give us false. So that's why I have incremented it by 6, because if I increment 5 by 6, it will give us 11, which is not specified in these three conditions. So now, so I will check if n modulus I, if it is equal to 0, or n modulus I plus 2, if it is equal to 0. If it is the case, then we will return false. Else, we will come out of this loop and we will print true. Okay, so let us check if this is also giving us the right output or not. Check prime efficient, and this is the case. Now we'll run it. So let's enter a number. So 2, yes, it is a prime number. 3, yes, it is a prime number. Suppose I have entered 78. 78 is not a prime number, so yes, it is giving us not a prime number. 9, 9 is not a prime number. So we say that we have implemented successfully the code of check prime number. So I hope you have understood it. Thank you.